Hello and welcome to our 12th session, and in this session we are going to discuss about transform orientations. To understand this, I will come into Blender, and in our previous session in chapter 1 itself we had understood that in a 3D space we are going to measure the position, location or rotation of any object based on three axes. One is the x-axis, which represents the left-right movement of your object, y-axis which represents the forward-backward movement of your object, and if I come to overlay here and if I enable Z, moving it to top or bottom represents the z-axis, and these axes we normally call it as the global axis. Say for example, I select this and if I enable the move tool, you are seeing this gizmo here. The red indicates the x-axis, green indicates the y-axis and blue indicates the z-axis. And as of now you can see that the axis of my object and the axis of my globe are the same. So now to understand this better, let us come into Google Maps. Say for example, when you open Google Maps, the default view that you are seeing here is from center to top. When you are moving towards the top, you are moving towards north. When you move towards bottom, you are moving towards south. And when you are moving to the right, you are moving to east. And when you are moving to your left, you are moving to the west. So this is what the default direction of your Google Maps. Now say for example, you want to create a route map from Bangalore to Mysore. Now what happens is, Bangalore is to the north of Mysore. When you travel through a car, say for example, you are sitting in a car and you are traveling towards Mysore. So when you are traveling in the car, this is your forward direction. So when you are moving north to south, now what happens is, when you are moving forward, you are moving towards south, and your right is now not east but it is west, and your left is not west but it is east. So now the entire coordination system is going to change when your direction of movement changes. And this is exactly what happens even in Blender. Say for example, when I add an object, right now the coordinate system of my object and my global is the same, and this will remain the same when I am doing the movement. So whenever I am moving it, pressing G, when I transform its position like this, wherever I move, during movement, the orientation of global and local will remain the same. Similarly, even when you scale, there is no change in global orientation. Now one thing here is, say for example, I have moved it somewhere here, I will press N and I open this panel, and now I want to reset it and bring it to the center. We are going to do it by coming to Object, Clear, Location. So when I click Object, Clear, Location, all these values will be set to 0, 0, 0. And the keyboard shortcut for this is Alt G. Always in transform, you will have location first, rotation next, and scale the third. And they have mentioned this purposefully because in all mathematical calculation, the order of hierarchy is location will first come first, and rotation will come next, and scale will come next. So to give you an example, say for example, as of now, if I scale this cube along the z-axis by 5 units, you can see it is now working fine. Okay, it is correctly scaling along the z-axis. I will now press Alt S to set the scale back to 1. I am going to rotate this cube along the y-axis by 90 degree. As of now, you are not seeing any change in these coordinates. If I scale it along the z-axis by 5, what you can see is instead of scaling it along the z-axis, it is actually scaling along the x-axis. So when I change z here, x is changing, and this is because rotation has a higher hierarchy than scale. So when you have rotated this object along the y by 90 degree, now z will become x, and if you want to move it along this, I have to now set z1 and I have to set x to 5, and now you can see z and x has got interchanged. And similarly, I will press Alt S and cancel the scale, and now instead of rotating it in y, I will rotate it in x by 90 degree, and now if I set the scale of z to 5, you can now see this is scaling along the y. Now what has happened is y and z has got interchanged. So if I want to scale it along z now, I have to press 1 here, and along the y if I type 5, now it is getting scaled. This you should remember, because rotation always takes precedence over the scale. So I will press Alt G and cancel it. I will select this cube, press X and delete. I will press Shift A, and this time in mesh, I will add a cone. I will press 1 and come into the front view. I will press N, and here I am now going to rotate this along the y axis by 45 degree. The orientation still remains the same, because right now we are in the global axis. Now say for example, I want this cone to travel forward, means for the cone the z-axis is not this. So if I drag it, see this is not moving forward. See, you can see the movement. This is not forward movement, or this is not the x movement for cone. So now for the cone to move forward, I want this axis to be set to the axis of the cone. This is just like you are traveling in a car, and for you the forward is not the z. The forward has tilted. You have turned the steering and you are moving at a different direction. Now in this case, we are going to come into another axis here, which we call as the local axis. And when I choose the local axis, immediately you can see how this changed. You are in global axis and I want to move it along the z axis. So the keyboard shortcut for movement is G, and then for the axis normally I press Z, and you can now see the axis it is showing. I can only move it like this, but if I press Z second time, you can now see this axis change to local. And now when I am moving it, you can see in the transformation both x and z are changing. Although I am moving it along the z axis, both x and z are changing. So sometimes when you want to move your object along its local z axis, we are going to make use of the local transform orientation. And this axis between global and local is going to change when you are going to use rotation. So whenever you are going to rotate your object, this axis is going to change. That's why here you have two options here. One is global and another is local. Now apart from these two options, you have another option called as the normal. In mathematics, whenever you have any object, say for example in this cone, you have a point here and this point actually has a line like this. So you have a diagonal line and the perpendicular line that runs to its diagonal line is called as the normal. I will press X and I will delete this cone. If I press Shift A, and I am going to add some other complex surface like a cylinder. If you see this cylinder, you have different faces here. Come into edit mode and I will select face selection. And now if I select a particular face, so exactly perpendicular to this, you have a line running, and that line is what we call as the normal. But you have a new menu appearing here next to overlay, and this is called as mesh edit mode. And when you open this mesh edit mode, you have one option here called as the normal, and you have three normals here. One is for the vertex, one is for the edge, and another is for the face. Say for example, I click on the face normal, and when I ask it to show it, you are going to see some cyan color lines running like this. And now in this case, now normal means this is the z-axis. And similarly, now if I select any of the vertices here, say for example, I select this vertices and I will come over here, and if I choose the normal, you can see the direction of this vertices normal. So it will be running exactly perpendicular to the tangent line. So every point has a normal. So now in case of this vertices, when I am moving it, if I change this to normal, if I press GX and move it, so this is the X orientation. If I press Y and move it, see this is the normal orientation, and if I press Z, see this is the Z orientation. Well, I will come into face selection. I select any one of the face here like this. So for this face, when I am moving it in global, I will press GX, and when I move it, see this is not moving exactly. See how it is moving? I will just press GX and move it. See, it is moving along the global axis. I will right click and cancel it. Now if I come into the normal axis and if I press GX, see it moves exactly flat like this. If I press Y, this is the Y axis, and if I press Z, see this is the Z axis. So I can move it and manipulate it like this. Z becomes the normal of your mesh, is what we call it as the normal mode, and this is the third mode. And then comes the gimbal. Now I am going to come to this gimbal in the end, because for this we have to understand something called as Euler rotation. So we are going to deal it in detail in a separate session. Now I will come to the next one. I will come back to object mode. Now I will press 1, press X, and I will delete it. Now I will press Shift A, and I am now going to add, say for example, a cone. If I set the option of this to view, and this will be this view transform orientation, we are going to use it especially when you want to modify something in camera view. Say for example, I press 0 and come into camera view, and I want to move this object closer to the camera. Then I can come here to the axis view, and when I choose view and when I select this, now when I press GZ, see you can see it moves closer or backward, because now moving it closer or backward is Z axis, moving it left or right to my view is the X axis, and moving it top or bottom to my view is Y axis, and this we call it as the view orientation. So this will be very useful when you are adjusting the object position in the camera view. So I want to slightly move it to the top or bottom, then this view option will help you. And then you have the cursor. Now cursor means, so I will press 1 and come into this view. Now I will come into the view, and you have this 3D cursor. Along the Y, I am going to rotate my axis by 45 degree, and you can see here the hairline turning by 45 degree. Come over here, and if I choose the cursor, you can now see my axis aligned with the cursor. So if I press GX and move it, it moves in this location. If I press GY and move it, it moves in the Y location. GZ and move it, so this will be the Z location. So based on my cursor rotation, this is going to change and I will set it back to 0. Now the next orientation I have is the parent orientation. So I will come back here to make you understand this. I will select this cone, I will press GZ and move it to the top a little, and then I am going to add a mesh and a cube. And now I am now going to select this, press GZ and move it like this, and I am going to now select this cube, shift click this cone, see that the cone is the active object. Now I will press Ctrl P and I am going to parent it. Now I will select this and I am going to rotate it along the Y axis by 45 degree. Now I will select the cube and I want to move this cube. Now I can now come here and if I select the parent, whatever is the orientation of the parent, this cube is going to move in the same direction. So now if I press GZ, it is going to move like this. If I press GX, it will move like this. Now I will middle mouse click and turn it. Now if I select this and press GY and move it, so you can see that how it moves exactly in alignment with the cone, which is the parent object. So to understand these orientations better, I will now come back here, file new, and I am going to create a new file. Don't save this. Press N to open the side panel, and in the X I am going to scale this along 5 units, and then along the Y I am going to scale it 5 units, and along Z I am going to scale it as 0.1 unit. So this is now appearing like a floor. So I am going to come here and I am going to call this as the floor. And on this floor, I will press Shift A and I am going to add an object like a cube. Now the cube is placed exactly at the center. I press numpad 1 and come into the view, and now in the add cube, I am going to move it along the X by 1 plus the thickness of Z, that is 0.1. Now it will sit exactly over the floor. Now here I am now going to press again Shift A and I am now going to add a cylinder, and I am going to set this cylinder depth to around say 5. I will make it 5 units long, and along the Z axis I will move it by 4.5 meters, and it is sitting on this cube. I will to slightly move it above. I will press GZ and move it above and place it on the top here, and I will move it by another 0.1, so make it sitting on the top. I want to show you another kind of parenting or relationship that we can build in Blender. Now I am going to select this cube, and this cube I want it to parent it to the floor. The other way I can do is, if I come into the object data, here you have one function called as relations. If I open this relations, you have one parenting, and in this parenting, if I click here and if I now select the floor, see now what happens. My cube has become the same size as my floor. So why is this happening is, whenever you are setting the relationship using here, whatever is the transform property of the floor, the same transform property will be applied even to my cube. So if I open floor, now cube is the child of the floor and it has got all the transform property of floor applied to it. So right now I will come here and I will click this into and cancel it. Now if I doesn't want this to happen, then when I select the floor, by default this floor is scaled by 5 units on x, 5 units on y and 0.1 unit on z. Now, if I want to declare that this is the actual size of the floor and this is the actual location, rotation and scale, then we have one function called as apply. So, if you come to object, you have two options here. One is clear and another is apply. So, if I come to clear and if I click clear scale, now this floor will retain the original size because all the scale is set to 1. So, now I will come to edit and I will undo it. However, if I come here in object and if I click on apply scale, see now what happens in the side panel. Right now the scale is 55.1, but if I apply the scale, see this becomes 111. Means whatever was the transformation that we had done to this floor, that has been standardized as 111 unit. And now if I come to the cube and if I come into object relation and now if I choose the floor, see now both this floor is also 111 unit and this cube is also 111 unit. And the keyboard shortcut to apply any of the transformation is Ctrl A. So when I press Ctrl A, you have location, rotation and scale. Say for example, similarly now, if I select this cylinder and I want this cylinder to be the parent of this cube, then I will press numpad 1, come into the front view. See now, if you select the cube, in cube it is moved along the z-axis by 1.1 meter. So this is the transformation that we have applied to the cube. Now I will select the cylinder and in the object data, if I parent it to the cube, then you can immediately see my cylinder also got that 1.1 meter transition applied to it. So that's why it has moved up. So if I cancel this, it will stand down. Now if I select this cube and see here the current location is 0, 0 and 1.1. Now I will select this, press Ctrl A, and if I apply the location now, you can now see the current location of our cube is set to 0, 0, 0 and the origin point of the cube is at this 0, 0, 0. So now if I select the cylinder, I will come over here in the relation and if I add it to cube, now you can see here that you have no other transformation that is getting applied. So remember, when we are building up the object relationship, that is when we group one object with the other, you can group it in two ways. One, coming into the relation and setting it the parent, and another way is to press Ctrl P and set the parent. And whenever we are setting the relation using the parent, we always apply our transform and see that the current scale, rotation and location are all set to 0, 0, 0, 0, 0, 0 and 1, 1, 1. Again here in file, new general, and I will click don't save here, and right now I have a cube. I will press 1 and come into the front view. Now with this cube selected, I will press G, Z and move it by 1 unit so that it is resting exactly over my axis. Then I will press 1 and come into the front view. Now I will again press Shift A and now I am going to add a cylinder and I will come into the parameters here and I will set its depth to around 6 units and then I will move it along the X by 5 units. And now you can see this cylinder is exactly placed over my cube. Now I will select this cylinder and I will scale it only along the X and Y axis, and Z axis I doesn't want to scale. So when I scale it, I want to scale it in the Z. So if you want to block one axis, I will press Shift Z. So now this is going to get scaled only along XY axis. So now I will scale it down and I will set the XY axis here to 0.5. Then I will again press numpad 1 here, and coming over here I will press Shift A, and now I am going to add a cone. And this cone I will press GZ and move it to the top like this, and I will move it by around 9 units to make it sit exactly over this cylinder. And now I will press 1 and come into the front view. I will call this cone as arrow 1. I will select this cylinder and I name it as axle, and I am going to select this and I am going to call this as base. Now I am going to select both the arrow, shift select axle, then shift select and select this base. Then press Ctrl P, and if I set it to parent, now this base contains the arrow and the axle. So I will also name this as axle 1 and also this base as base 1. So then I am going to select this base. I will press GZ and move it along this direction by around approximately 4 units. So I have moved it to the top by 4 units. I am now going to apply the location. If I press N and open the side panel, the Z location is set to 5 meters here. So if I press rotate and rotate it, it is rotating around this axis. Okay, I will right click and cancel it. Now I will press Ctrl A and I am going to apply the location. So now its origin point shifted over here. Now if I press R, it is going to rotate around this axis. Now I will select this, press Shift G, and here I will choose children, and in the option here when I click extend, now what happened is all the objects which are the children of this cube base is selected. And now if I press Alt D, if I press R, Y and rotate it by 45 degree, you are going to see this rotation. Then I will just press Shift R once, twice, thrice, 4, 5 and 6 times. Now I will come into my outliner and I am going to name this as base 1, base 2. So this naming is to avoid confusion for me. I will name this as base 3. I will click here, paste, and base 4, and then this is base 5, then Ctrl V, paste base 6. I am going to call this as base 7, and this will be base 8. So I have 8 bases here. I will press Shift A and I am going to add an empty plane axis. So a plane axis empty is added here, and for this empty I am going to call this as AXIS, axis 1 in capital letter. And then now I am going to select base 1 to base 8. With Ctrl press, click on axis 1, so that axis 1 is the active point. Then I will come over here and press Ctrl P and I am going to parent it. So now this axis 1 contains all these rotated arrows. I am now going to select this axis 1, press Shift G and I am going to click on children, and here I see I will disable this extended now because I doesn't want the center axis to be selected. So I will disable extend and I am going to select only the children. Now I am going to press Alt D to duplicate it. Then I am going to press R Z and I am going to rotate it by 45 degree and press enter. And now you can see how the structure is created. Now I will press Shift R and I will rotate it 3 times. So now you can see a structure like this created, and all these are present inside the axis 1. So, you have an arrow like structure created over here. So, I will press 1 and come into the center, and finally at the center I am going to press Shift A, and I am now finally going to create one UV sphere, and I am going to call this UV sphere that has been created as, I will call it the main in capital, and then I will select this entire axis 1 with control pressed. I will select main so that it is the active one. I will press Ctrl P and parent it. So, we have just created a structure wherein I have a main, and if I just select this and if I press Shift G and if I select all the children and click on extend, and if I just Alt D and duplicate it, I have the entire set duplicated over here. So, I have created a structure like this. I will press X and delete it. So, this structure we are going to use it later to define our orientation and also to define about our Euler rotation. So, what I want you to do now is, you have to create a structure like this wherein all these arrows are pointing in different direction and you have one sphere at the center. So, create this, go to File and choose Save As, and give this in your folder, give it the name as 17 underscore arrows all directions and click Save. So, with this we are going to conclude this session, and in our next session we are going to discuss one last orientation, that is the custom orientation, and we are mainly going to concentrate on Euler rotations.